Today we're going to be doing some more shader stuff. Specifically, we're going to look at this shader tutorial I found by the same guy whose shaders we analyzed at some point. He has 3 tutorials on this gmshaders.com. We're going to look at the Turbulence one and maybe create something like this. So there's some introduction, and then here we get to the code. But before we do that, let's go into our project here and say ergo run release, and we want to make a new project called let's call it Turbulence tutorial. So it's just going to build. While it builds, we can go here. So he has some explanations for different methods he uses, and in the end, I think we'll create something like this. And we'll just try to walk through each thing step by step and try to understand it. So the first thing he does is so here we have our project finally compiled. The first thing he does is to change the actual position of the x-coordinate. So let's try to do that. And let's open project Turbulence tutorial, and here we go. So what do we need? We need a frequency, basically. So let's define, or let's not do it like that. Let's just say frequency is 1 for now. Then we're going to say position is wave amplitude. I think he uses a macro for that, or like a define. So let's just define it like this. And then we have sine of the position in y times frequency divided by frequency. All right, but let's actually open up a shader. So obviously we cannot see anything. So how should we color this? Is the real question. Maybe we'll make everything the same color, and we can try to. It will make it gray. We can try to do this, and that does not work because this is like varying. So actually we have to make a second variable like that, like that, like that. I think that should work. All right. Now we have something like that, which looks nothing like any of the pictures, but that's to be expected. We're only just getting started. Yeah. What if we change the frequency a little bit? We get something like this. So we can kind of see some waves here already. All right. Let's just try to keep moving. I mean, basically, you can imagine that we have this grid, and you're kind of displacing these red lines. It's only like a way to think about it. It's not really something we're gonna visualize right now. All right. So then we have the phase. Float phase is the frequency. There's some kind of rotation matrix that we need to define. Time shoot time. So it's probably just going to be time for us, and we need another define. It's just going to be, well, what does he have it there? He has a 0.3, and he has the amplitude as 0.7, which I guess fine, we can do that. All right, we still need a rotation matrix. And by the way, we have amplitude, rotation 0. So this is kind of a strange thing. Okay, we're kind of rotating everything, and then so it kind of gives you a different phase in different directions, I think. So we need to see what the rotation matrix is. And he has it here. 6, 8, 8. Right, fair enough. Let's try to see how that looks. It doesn't look super different. What if we change something? Actually, what happens if we don't have this? It looks like that. So kind of difficult to see, but all right. And then it's all put into a loop. So I think that's where some of the really interesting stuff comes, like doing it multiple times. And for some reason now he changed the name of the variables, but that's fine. That is fine. So we have an amplitude, we have a speed. Let's also add the number. Let's add the frequency and this exponential thing. Right, so we start out at this frequency. We have the rotation matrix. And this one we also need. That's just in the beginning. For some reason this is a float, but whatever. So we adjust the phase, we do this thing, and we actually don't use this anymore. So what was the point of that? All we need to do is add some sine wave displacement. We'll need to rotate each wave separately to create some curves or break up the visible alignment patterns. Sure, rotation angles super important as long as flows look natural. Making a simple horizontal wave might look like this. Fair enough. Okay, it's the same. I think I understand it now. It's the same idea. Before we just had y times frequency, but now we have this rotated thing. Plus some kind of like offset in time that changes with time. And then we use that. Okay, fair enough. Then the rotation thing, we change the rotation a little bit every time, and we change the frequency. And now if we look at this, you can see it has some more patterns and it's kind of changing in time. All right, that is cool. And what we should do, like, so here he has some different things. Actually, maybe we can do something similar. What if we say px, py at 0? Kind of looks like that. If we do +1, no, it's not good. Do minus py. And then we can try to, I'm not sure like how useful this is, but you see we kind of get like smoother patterns. And if we go all the way to 100, it's going to be super noisy. So let's just stay with 10. All right. So far so good. We have some kind of noisy thing. And we can increase like the number of times we go through. We'll add more noise. What happens if we change some of the other parameters, like this one? It will probably also make it more noisy, yes. And if we like make this very small, it's just gonna be smooth. So let's do that. And this one also gonna make it more noisy. Wave speed, if we change that, it should change much faster. All right, great. But this is not very good visualization. We want to create something like that. So I think we have to look at this demo right here. And here we see this is exactly our code, and it returns just the final position. And then this is the the interesting thing, the actual coloring. Well, it's also nice to know this technique of creating waves and whatever. All right. So we have here some kind of color that depends on X. Not like that, like that. So what if we just add that here? Changes a little bit. Then there is this thing. All right. Maybe this should go from 0 to 1, so we can say it's 1 divided by 2. No, it doesn't really make a big difference. Let's keep it like that. All right, that doesn't really look like this. So what went wrong? Maybe it is supposed to go from frag counter times 2 minus resolution. It is supposed to go from -1 to 1, I think. But we can just try this again. No, it's not that. What? That helps a little bit. But maybe we messed up some of the numbers here. 7, 3, 10, 2, 1.4. We have the same matrix. Multiply, multiply. This thing. There's an extra plus here. Plus I. Okay. Still not right. It's very interesting because it's supposed to be exactly the same. Something must be wrong. Let's try to copy this and put it here. Just for a second, we'll do this. And this one is called out color. This one is just called main. That's not a thing. This one is called plus. There's no resolution. I still think this is just position. There's no I time. That's fine, it's just time. All right, it looks a lot better, which means that we have certainly done something wrong. Let's maximize it and compare. To me, it looks exactly the same. Like that. It's 10, 7, 3, 2, 1, 4. The colors are also supposed to be the same. right, let's try it again. It just messes up. Yeah, I don't see it. What if we change this and we just say, actually, just apply turbulence to that. No, still wrong. That means it's something here. Okay, after much searching, I found the bug. So it should be P here, not position, it should just be P. So let's get rid of that, and now it looks correct. And we can go ahead and remove all this testing code to simplify it a bit. All right, and now the interesting thing is, now we can play around with it. So if we make this one larger, okay, that did not have the effect I thought. What if we make it smaller? That just fucks it up. What if we make it 10? What if we increase the frequency? That's kind of interesting. It's too much. What about the amplitude? Oh, that's super cool. Actually, it's a bit too much. We can try to take a screenshot. Now we should have a screenshot. What if we open that? Looks pretty cool. All right. We can also just take a screenshot. Normal screenshot. All right. So probably if I say X here, it shouldn't change much. It did change something, which I don't fully understand why that should matter. So let's change it back. And what is this? Like, why do we need that? Okay, we don't really need that. Just change it a little bit. And how about this one? If we change that to maybe put the 8 here. Like that. It's not too big of a change. We can try to have some more components. All right, like after 10, you don't really see any change. Try the amplitude. This is just the speed at which it changes, not so important. And the frequency also doesn't really qualitatively change it. If we make it too high, it's just gonna be noise, that's fine. All right. I guess like this stuff is not so crazy, like we're rotating the position, we take the Y component to give the phase. Then there's also this thing that we use, which I suppose it could be any vector 2. What if we do 0 like that? So here you can kind of change how it looks. I'm not sure. I'm not sure why it's so great to use this thing from the rotation matrix. Maybe it's just lucky. I don't know. All right. What's next? What's next? Then we have this kind of thing. And actually what is going on here? Yeah, I'm sorry, but this, like, it makes very little sense to me. This doesn't change so much, like, so we kind of mixed P up, like shifted it around and done a lot of stuff. Like, what happens, maybe it makes a little bit more sense if we put 0 here. So this is like the original coloring that we get from this code. But then we're just doing a lot of like mixing all the pixels up, like those same pixels, but just like moved around. So we get this kind of thing. So I'm kind of guessing that, you know, we have this thing that mixes around all the positions, and maybe if we do something else, it will also be interesting. And then there's this thing called the Baker's map, which is applying this function again and again. So maybe we can try to do something like that. And we basically want for float, let's just keep some of the same constants, even though it's nothing to do with turbulence anymore. And what we want to do is like if p.x is, so maybe now we want to make it go from 0 to 1. So if px is less than 1/2, we are going to say p is equal to vector 2 times p dot x and 1/2 p dot y. Otherwise p is 2 minus 2 times p dot x and 1 minus 1/2 times p dot y. All right. Let's see if we can find this thing. It looks amazing. It's absolutely amazing. Right, so we have this to begin with. Maybe if we change it, no, I guess it's okay. If we remove that one, maybe we try something like this. Okay, it's just gray. So this should make it a little bit more blue towards the edge. And we have a minus there that we shouldn't have. All right. What if we... Okay, like that, which I'm not sure I understand. So this is a very large number. No, whatever. So we have that, and then there's something here where you're like doing some weird stuff. What if it's just like that? Becomes very bright down there, but maybe we... Don't think I want that. Trying to get some kind of interesting coloring. Maybe we just keep it even more simple. We say like it's px 0 py, so something like that. Let's apply this map, and it just becomes, get these very annoying lines. Did I do something wrong in the implementation? There's also this thing. That should be the same. Okay, so it's actually not that interesting, I think, this map. All right, how about we try this one? It looks kind of interesting. So let's get rid of that. Let's say again, let's actually just copy paste that. All right, so p.x is equal to, or let's make a new p. It's just a copy of p. New p.x is equal to p.x times p.x minus p.y times p.y plus a, which we haven't defined yet, but we will soon, and b times p.y. New p.y is 2 times p.x times p.y plus c times p.x plus d times p.y. All right, and then we have a 0.9, b minus that, and 2, d is a half. All right, and finally, of course, we need to like reassign like that. And let's see what that does. A little bit interesting. Let's go back to the color map from before. Get something like that. And maybe now we don't want this, we want it like that. So we definitely do get some interesting shape. Problem is just that we get some kind of weird behavior on the edges. So what if we say p.x minus a little bit? Should move it, and maybe we even scale it a little bit more and move it a little bit more, and maybe even scale it even further. Okay, now we have this. It's a little bit unfortunate. Maybe we, yeah, maybe we don't do that. This is just bad. All right, what do we do? Let's put this in a in a sigmoid function. Is that a good idea? Maybe. No, this doesn't fix the edges. I'm not sure what's happening there, but all right. Wow. Okay. Now we need to make this uniform float. No, sorry, uniform int num. Let's get rid of that. And here we just have the num. All right, and let's add a value for that. So number, and it's going to be between maybe 50, 0 and 50. Now we can definitely get some interesting shapes. Even already at 2, that was kind of interesting, I think. All right, but that's not sure what else we can get out of that. I mean, we could try to change some of these numbers. Checkers is float a, and we don't get that a value, we do like that. All right, we have a, maybe it should only be between 0 and 1, maybe even -1 could be interesting. That's like some negative numbers. All right. All right. Let's try to see if we can find one more map that's kind of interesting, and then we'll call it for this video. All right, so we have something here. Let's see if we can make that work. And let's just comment that out. And now we have P and theta, but just think of them as X and Y. We need a K. So let's say K is 0.6. And then we want to say again, for some number of iterations, we're going to say, now we can actually do it in place. So we're going to say this is equal to the old one plus K times that stuff. And the Y is the old plus the new one. And already we have something somewhat interesting. Let's make this guy a uniform as well. So it's actually faster just to write that. And here we go. Okay. And which kind of ranges do they have here? They have maybe like 0 to 2 is a good guess. Nothing is really happening. Did we save? Not sure what went wrong. Does it just stop? Maybe that's the problem. It fails. When it fails to find one, it just stops. Yeah, I think that was the problem. Great. What if we do like that? Do like this. That's interesting. Like, why does it? Well, we multiplied by 6 here. If we go back to multiply by 1, this looks like that. So this is what we start with, and then we mix it and mix it and mix it. All right. I think that's gonna do it. I hope this can inspire you a little bit. You know, you can go look for different mappings, starting from, for example, the Baker's map, and then you can look the Wikipedia links and try out different things. So I will see you in the next one. Bye bye.